Very good afternoon, everyone. It is my immense pleasure to introduce a resource person for this third session of ATAL Learning Program on IoT. Dr.C. Christopher Asir, sir, Professor, Department of EEE, Pondicherry Engineering College, Pondicherry. Dr.C. Christopher Asir, sir, has completed his BE degree in first class with distinction in Electrical and Electronics Engineering at Metropolitan Engineering College and his MA degree in first class with distinction in Power Systems Engineering at Tyagaraja College of Engineering, Madurai. He was a third rank holder in BE and second rank holder in ME. He has also finished DIS degree in first class with distinction at Annamalai University, Chidambaram in the year of 1992. He has completed his PhD degree in Power System Optimization at College of Engineering, India in the year 2004. He is having totally 26 years of teaching experience in various reputed institutions. He is presently working as a professor in the Department of EEE, Pondicherry Technological University, formerly Pondicherry Engineering College, Pondicherry. He has published 222 research papers in various national and international conferences and 187 research papers in various international and national journals. He has produced He has produced 10 doctoral scholars. He is presently guiding 3 research scholars. He has published 3 patents. He has presented one of his research papers in Japan during 2002 in the IEEE International Conference on Transmission and Distribution Conference and Exhibition, Asia Pacific 2002 during the AICTE Young Scientist Scheme and DST. He has also visited National Technological University and National University of Singapore for his technical assignments. He has presented one of his research papers at Thailand during September 2011 in the International Conference on Utility Exhibition 2011 on Power and Energy Systems, Issues and Prospectus for Asia. He has completed the AICTE R&D project on development of improved solutions to unit commitment problem through intelligent techniques with a cost of about 4 lakhs as a principal investigator and the AICTE RPS project on investigation on power system harmonic load detection and elimination analysis using intelligent techniques with a cost of about 8 lakhs as a principal investigator. He is currently doing the project AICTE RPS on development of hybrid algorithms to solve the unit commitment problem in smart grid network using soft computing techniques with a cost of about 12 lakhs as principal investigator. He received the Rashtra Pratibha Award by Integrated Council for Socio-Economic Progress, New Delhi on 22nd December 2004. His name was included in Who's Who in Science and Engineering in the World for the most important contributor to engineering profession in the year 2004 by Marquis Who's Who, USA. He received the Mother Teresa Excellence Award by the Friend for National Progress, New Delhi on 27th May 2005. He was selected in the 2000 Outstanding Scientist of the 21st Century for the Outstanding Research to Engineering in the year 2005 by Cambridge, England. He received the Young Engineer of the Year Award by Energy Society, Bhopal on 25th October 2007. He received the Outstanding Achievement Award by the Energy Society, Bhopal on 25th October 2007. He received the Certificate of Merit Award for his paper published by the Institute of Engineers, India, Kolkata on 12th December 2002. He received the Exceptional Academician Researcher Award by the Engineering Today, Malaysia on 11th March 2017. It was organized DST, CSIR, DST, Puducherry, PEC Puducherry sponsored National Conference on Computational Intelligence to Emerging Electric Power Systems. In September 2006, it was organized the Energy Society DST Puducherry sponsored National Conference and Exhibition on Demand Side Management Options for Energy Sustainability on 25th December 2007. He was organized as one of the coordinator of the IEEE Faculty Development Program on Natural Computation in Engineering year of 2010. Was organized as the AICTE Staff Development Program on Computational Intelligence to Power System Analysis, Control and Optimization during June 2011. He has organized AICTE Quality QIT sponsored 1 week short-term course on applications of microgrid in distinguished distributed generation together with clean energy technology from 21/1/2019 to 2/2/2019. He has published the books on the title Electrical Energy Generation, Distribution, Special Electrical Missions, Electromagnetic Theory, Solar Technology and its Applications, Advancements in Engineering Technology, Principles of Management. He acquired Fellow in Institution of Engineers India, member in Society of Technical Education India, member in IAC Hong Kong and senior member in IEEE USA, member in ITERP India, and senior member in ISEEE Malaysia. His area of research is the optimization of power system operation, planning, and control through soft computing techniques. We are privileged to have the resource person, Dr.C.Christopher Asir Rajan sir in this session to share his knowledge in the field of IoT. Welcome you, sir. Thank you.
Thank you, madam. Thank you for your nice introduction. Why the share button is not enabled?
Yeah.
Can you make it to enable?
Yeah, yes, sir.
Share.
Yeah, sir.
Yeah.
Yeah.
Sharing is not enabled.
Yeah, sir. I will sort out that, sir.
Okay.
Yeah, now you can present, sir.
Yeah. Yes, ma'am. Yes, ma'am. Thank you. Thank you very much. Sharing is not working. Yours is coming.
Actually, sir, you just first open your PPT first. Sir.
I already opened.
Yeah. And just press share button in that WebEx, sir. Yeah.
Again, I'll try. What was it? What is the problem? Why it is not sharing?
Yeah, actually, sir, after opening your PPT, just press that share button, sir. After that, you having some
Yeah,
options
press
which
the
screen to
already.
share. So in that, if you have opened your PPT, that PPT screen will appear in that option. You just click onto it.
Yes.
Yeah.
Yes, it is like
Mm.
still going up. So not able to open. Why?
So have you minimized your PPT, sir?
Yeah, it is there.
Yeah, yes, sir. Now your screen is visible, sir.
No?
Yeah, yes, sir. Your screen is
Okay, okay,
visible.
okay. No.
Yeah.
Okay, sorry for the delay.
No issues, sir.
Thank
No
you for
issues.
your
We can continue.
thank you for your guidance. Okay, good afternoon, all the participants for all connected here for attending this ATAL FDP program. Today, I'm going to discuss about the application of IoT for intelligent scheduling of devices for efficient energy management in smart grid. So this topic is actually to discuss and share about the how intelligently we can schedule the devices in our home. At the same time, how we can able to save the energy, electrical energy. At the same time, how to efficiently we can operate our devices and apparatus within our premises as well as our home or industry or company, especially in the smart grid environment. I think all of you know about what is smart grid. Now we are going to discuss how this smart grid environment can helpful for uh, maintaining the intelligent operation of all the smart devices which is installed in our premises. This is the contents of my presentation. First, let us define what is Internet of Things, sample IoT devices, and then we are going to discuss about what is smart, why it is important now, and IoT in power grids and homes, and smart grid and smart meter, home energy management, hardware setup, external results and discussions, and conclusion. We all know that this is one of the definitions for Internet of Things, the things having identities and virtual personalities operating in smart spaces using intelligent interfaces to connect and communicate within social, environmental, and user contexts. So, how best we can connect our devices and communicate it for all the variety of applications, not only social, environmental, and user, apart from that, all the variety of applications wherever we are concentrating nowadays and we are contributing nowadays and we are innovating nowadays. All these applications are very smartly connected with the help of smart devices and not only connected but also to operate all the devices intelligently. That is very important. So once you are operating all the devices intelligently, then we can automatically save the energy, we can improve our economy of the power generation, and we can increase the efficiency of the system, and we can improve the reliability of the system. And at the same time, the tariff which is employed or which is calculated for each and every houses as well as commercial and industrial load are as minimum as possible. Other definition is extending the current internet and providing connection, communication, and networking between devices and physical objects, or simply we can say things. Is a growing trend that is often referred to as the Internet of Things. Or in other words, technologies and solutions that enable integration of real-world data and services to the current information networking technologies are often described under the umbrella term as Internet of Things. Okay, why should I learn about IoT? What is an SCP? There are a number of emerging technologies nowadays comes. Even through mobile, we can communicate. We can not only communicate, we can do all the variety of services, or being the bill, or we can monitor it, we can control it, or we can know what is the status at this time or at this second in other world, that is in other countries, sorry, other countries, what is the status of the particular device and what is the design they introduced at each and every second. Okay, some are listed here. Growing IoT services and applications in various areas like smart cities, healthcare, transport, logistics, retail, safety and security, etc. So apart from these applications, especially for the business trends and wherever there is a new opportunities are raised, There they can implement this IoT to immediately it can able to reach out to millions of within a fraction of a second. That is a major advantage and benefits of IoT. Especially for the business people, this will be very helpful for them to improve their profit and extend or enhance their business in worldwide. For this particular application, this is very much important, very much useful, and very much uh, we can say in other words, it will be the life of them. Uh, we can say simply for their life, business life. Without IoT, their life that life will not be completed. Like that, without IoT, they cannot do any business nowadays. Because earlier we are prepared some pamphlets or we are prepared some notices and we will go there and we will issue to the many people or many area and they will find okay this is a shop or business where commercial centers are there so we have to go there and buy everything. But now everything is in our hand. We can able to see through the mobile phone or laptop or tab or anything else. Any communication media, we can able to understand what is going on in the world and what are the components are available, what are the different informations related to all the variety of applications, whatever listed in the previous slide. So this will be the real picture of IoT. This PPT, just look at it, what are the other applications we can see in many applications apart from this picture. So through this only we can connect the complete world with our communication media. So people are connected to the internet through the mobile phone, and through the mobile phone we can receive as well as we can send the information to the different web or different locations through the internet connections. It may be received at any foreign in the world, and the information always stored in the cloud. And whenever it is required, it can be able to download it, and we can able to send it also. We can store it also. So this is possible only with the help of IoT, and there is a dual communication between the user as well as the cloud data. And this picture again shows other application of the, especially for some criminal activities can be identified through this IoT, and this will be helpful for the police department. They can able to understand where the vehicle is there, where it was kept, or where the people are doing some malpractice with that car or any mobile van or vehicle or any truck or anything else. So for that, they used some devices, and 1, 2, 3, and there is AMR, and this information will be received through either 3G or 4G or 5G or through Wi-Fi connections, and that information will be collected in the control center, and from the control center to the police department or the department which is required this data can be able to retrieve from that cloud data which is available in the control center, and they can take the remedial actions or corrective actions immediately, and that actions will be again transferred to the department people, and they will go there and they will do all the corrective actions and other repair or any remedial actions is required in that place or in that component, it can be done. And overview. This is the overview of the hardware platform which is employed in the IoT. You can see the for the user or environment, there are number of sensors and actuators, and there are some communication networks. Both are linked together as a device, and this device can able to receive some information from the area where it is located. For example, smart sensors are located at some location. From that location, the information will be collected through these sensors, and that will be communicated to the network. And in the network, there are a number of gateways are there. Through that gateway, the data will be transferred to the internet. And from the net, using server, we can able to download all the data from the internet. At the same time, suppose if we want to do uh, some control actions, if you want to generate it, you can do it, and you can send through the same way how you have received the information from the sensor. So from the sensors to the servers, there is a common link between these two through the Internet of Things, or we can say the Internet. So these two are divided into two different levels. One is device level and network level. And most popular RF system employed in this sensor or actuator is IEEE 802.4, 15.4 with 2.4 gigahertz RF system. This is one of the examples. There are many other sensors are also employed. And this is a basic hardware platform which is employed for the uh, Internet of Things operation. And let us discuss one by one for sensors and actuators. First, for sensors, they are mainly input components. They sense and collect surrounding information. And basically, there are three types: passive or omnidirectional, passive never deep sensor, for example, PIR, omnidirectional, for example, in and active sensors are sonar, radar, etc. Actuators are the mainly output components. Through this only we can actuate all the control activities. They alter the surrounding and they can able to change the present position of the component with the help of receiving the control signals or control functions from the control center. Some of the examples are listed out here, that is adding lighting, heat, sound, etc. Controlling motors to move the objects, displaying messages, and etc. Things are we can turn almost every object into a thing. The thing still looks much like an embedded system currently. A thing generally consists of four major parts. One is sensors and actuators, microcontroller. Third is communication unit. Fourth is power supply. A thing has the following properties. It is usually powered by battery. This implies a limited source of energy. It is generally small in size and low in cost. This limits their computing capability, and it doesn't usually perform complicated tasks. Power consumption is the main design issue. Will occur always. How much power we can able to utilize for this operation. That is also important because we have to pay unnecessary the electricity charge for the mm, power consumption, which is not properly scheduled or committed. Communications. A thing always feature having communications for team working. There are a number of communication networks are available nowadays. The main role of the communication network is providing a data link between two nodes. Types are wireless or wireline. Example, copper wires or optical fibers. Wireless, for example, RF or IR or RF-based communication is the most popular choice, and also our focus. Popular RF-based communication solutions are listed out here. AAA 802.15.4. It is used in HM1000 sensor or devices. And another one is for Wi-Fi, 802, 802.11. And sometimes we may use Bluetooth or near field communications like NFC, for example, RFID networks. The role of network is managing nodes, for example, discovery, join, leave, etc. Relaying data packets from the source to the destination node in the network. Networks are a distributed system. All nodes need to perform networking related tasks. Web-based network in IoT is usually a wireless multi-hop network. Some of the examples are shown here: wireless sensor networks, mobile wireless networks, wireless mesh networks, vehicular networks, and others. Main concern for all the variety of this RF-based networks are reliability as well as the good quality of service, or we can say in other words, performance. So these two should not be compromised at any time for any type of network, WSN, MANet, or WMO, or VANet. The internet serves as a wide area networking for a local network. The network uses TCP or IP. This implies that things must also support TCP or IP internet protocol. And gateway async is used for practical deployment. The gateway is often needed in a network. It offers relaying packets between the network and the internet. You can just see the picture, you can see the data are taken through the data link in the network. And there is a gateway to transfer the information from the network to the internet, as well as from the internet to the network. The protocol stacks consisting of different things as source, and there are some servers which is act as a sink. So mostly in the Internet of Things, having one application software and DCP or UDP network and network IP or IEEE 2.0, 5.14, PHR missing. These are the example thing is shown. Apart from that, many other things are available. Through wireless medium, it is transferred to the network where there is a gateway. It is also having a network IP. And similarly, IEEE 802.3, IEEE 802.15.4, both in Ethernet and PHYR and is available. Through that, the data will be transferred to the net, and from the net, the server can receive the information, and also it can able to send the information to the net, and it will be received at the smart operating device, which is located at the which is connected or linked with the Internet of Things. So within the server, there is also a application software and TCP or UDP is present, and there is a network IP, and there is a Ethernet which is employed to receive the information. With IEEE 802.3 is normally employed. This flow direction is shown from the Internet of Thing or Thing to the server. And regarding security and privacy, there are many questions are there. One is, are they important? Yes, it is very important because wherever there is a confidentiality is maintained, definitely we need some security is very important. Otherwise, some cyber security attacks may occur that can capture some information, capture some data, or they can insert some viruses, or they can change the format. Right, like the number of cyber security activities are there. So in order to curtail these cyber activities, we have to provide the proper security as well as we have to maintain the privacy for your network. So what is the risk? Yes, it is having the risk when you are employing some communication network as well as the security system. We have to employ some intelligent operation in the security system as well as in the communication network. Okay, what are the challenges are there when you implement the security or when you are concerned on security and privacy? There are some challenges are there like device level, network level, system level, or in the user level. All these categories we have to face number of challenges in case of devices, in case of network, in case of system, or in case of user. And what are the solutions for this? There are a number of challenges are there. Here I have listed out only four, but what are the solutions? We have to identify which particular security system is suitable and which privacy environment you are going to provide to safeguard your information without loss of any data, without loss of any information. The information or data should be transferred from the source to the sink. This picture shows how this will be taking place in the uh, sample data communication in conventional network. You can see number of terminals and number of communication devices, and there is a network which receives the information from the communication device, as well as it can able to send the information from the device to the communication device to the network. And there is a center and receiver is there. From the center, the data will be uh, transferred through the communication network and the internet, and through the gateway, the data will be received at the server. And in the bottom picture, you can see another sample data communication WSN network. So here you can see the data. Some bits of data is transferred from one node to the server to the core network, for example, internet. Okay, through the gateway, that information will be transferred. Suppose another data is transferred, but it is having some virus. Then that may attack the server. And where there is a program you have programmed, that will be completely collapsed because of this virus. So how to intelligently we can process the data? That is a major important task. We have to follow it, and we have to stick on to this to meet out these challenges. First one, the sensing and data collection. How you are sensing it, how you are collecting the data through the sensor, and what is the nature of the data, what is the format of the data you are collecting it and transferring it. Or network, through that network we are transferring it. That should be identified first. And then access, subscription, and integration. How we are accessing it, or through some subscription, or through some integrating device. Then there are some data processing analysis and clean data analysis are available. That through that analysis we can process the data and we can analyze the complete data which is received from the network to the server. And query and discovery. Suppose there is a query asked by the consumer, immediately for that query answer should be displayed on the screen. That should be already loaded. How it can be loaded for different mind setup? They may have different variety of questions, right? That questions you have to prepare the answer, like you can ask the question, and how you are discovering it. Suppose some new questions arise, how you are going to answer it. That should be intelligently operated with the help of some specific analysis and procedures or algorithms. And then data classification and clustering. What type of what methods? What are the methods you are using for classification and clustering procedures? These are the different areas where we can employ some intelligent algorithms or intelligent techniques to improve our complete network in smart way or intelligent way. We can make our complete network as a smart network. Other challenges are listed out here: multimodal and heterogeneous, noisy and incomplete, time and location dependent, dynamic and varies in quality, crowd-sourced data can be unreliable and requires real-time analysis. Privacy and security are very important issues, and data can be biased. So we need to know our data for that. Semantic, other technologies and connecting things to the metadata models, and sometimes some schemas are employed, and linked data and linked IoT data concepts. Then semantic technology, semantic sensor network, then interoperability issues, web things. These are the common semantic technology, other connecting things to the web. Let us see the basic devices employed for the data interoperability. So here you can look at it. There is a mobile one, and there is a band, and there is a DAP, and there is a other variety of connecting the Wi-Fi modem or other mobile communication devices are listed out. Here it is displayed as a picture. can just look at it and you can get the idea. Let us see what are the system models, applications, and standards. Applications are we can employ for the smart home, individual home, then the complete smart city, then healthcare and smart grid. And physical cyber social systems, we may use it. And machine to machine communications, we ought to maintain some standards and models and system models and standards, complete system models and standards. Let us see some of the sample IoT applications. So you can see other applications are listed out with along with the picture. There is a smart grid network, smart health network. From there, we can get all the variety of health-related issues. We can get the solutions. We can get the medicines. We can get the remedial procedures or actions or exercises or anything else related to the health. And regarding smart home, all the smart appliances are employed instead of our conventional appliances. And the complete once all the homes are converted into smart home, then the complete city will be converted to smart city. And regarding industries, also converted into smart industry. And then normally we are using nowadays smart TVs. Uh, the olden designed TVs we are replaced. And like band, the smart watch, and smart car, smart text. These are the other variety of applications. Just to know what are the other variety of applications we are buying IoT. Apart from that, all the simplified blocks are shown here for the complete Internet of Things. You can see variety of devices, mobile phone, printer, monitor, and there are some amplifiers or Wi-Fi or smart home, cars, HEV cars, audio systems, video systems, and lighting, oven, washing machine, navigation, or CCTV application, or the walkie-talkie, or the Wi-Fi operating devices. Okay. Now let us see what is smart. Passive. Communicate only when queried. Whenever it is queried at that time, only it will be communicating the answer. Passive RFID, QR codes are normally employed. The software employed are NVIDIA. And active communicates whenever it is needed. That time alone it will communicate. Other times it won't communicate. There are a number of sensors and home automation devices are employed. Between 1 to 4 since normally employed for the home automation. Nowadays, with many sensors are provided for the home automation system. And aware, action based on simple computation. For example, telehealth. It is operated with 5 sense, so we can able to understand what is the status of our health and what are the other parameters relevant to the health status. How to improve our health conditions, everything will be discussed under this aware task. And autonomous can make decision based on tools like autonomous cars, smart grid, human. It can be taken its own decisions based on some standard rules. So we need not to have any persons to analyze it and persons to operate it or persons to control it. So instead of that, it can understand where there is outages and it can able to try to solve the problem by self-heal the network. That's why it is mentioned as autonomous. So this bar chart shows the 10 most popular Internet of Things applications where we are using it. 100% we are using it in smartphone. Many of other countries are already implemented a smart home in the complete country. Right? Based on their statistics, only these bar charts are preferred, and the wearables like bands and etc. 63%, and smart cities 34%, smart grid network 28%, industrial internet 25%, 19% for PHEV connected car, then 6% for connected health, 2% for smart retail applications, and 2% for smart supply chain activities. Okay, why it is essential? Why it is necessary now? Because we have affordable cost of sensors are nowadays available, and many processes are available in the net as well as just commercially available with cheapest cost. And bandwidth also we can able to get it less cost. Apart from that, we have smartphones. Everyone we have nowadays smartphones, so it can be able to integrate easily with the Internet of Things. And the ubiquitous wireless coverage and big data network, IPv6 network are available nowadays, and we are mostly using it. So these can be easily adaptable with the available communicating device like what you call the mobile phone. IoT systems specified. Start from the consumer and home. There are a number of other blocks are linked with the network, and how IoT will be useful for different applications. We can see from this slide all the smart infrastructure, security and surveillance, transportation activities, then other activities also bottom right. You can just look at it, what are the components you have like. And then industrial application, the device is employed are shown. And then for retail application also shown. When you compare this picture with the earlier discussion, you can easily able to understand why we are moving to the smart network or smart system. And apart from that, healthcare application, this is very important apart from everything, because we have to get very good operation, very good services, and a good efficient operation of the system. This can be achieved only with the help of the IoT system. IoT in power grids and home, especially for power grid corporation, how the IoT is different systems. One is smart home, consisting of all the smart appliances in home which communicates with each other and are able to take decisions on each other readings. And power grid, power distribution to the smart home and the guideline pricing based on the fast peaking hours or fast peaking hours wherever you are seeing. And smart meters. Smart meters are the digital energy meters with a smart chip and scheduler which can make decision on really the desired output or desired home appliances based on the guidance price received from the power grid. So already they published in power grid software. You can just search it and you can able to find out. And smart meters are the digital energy meters with smart chip and scheduler which can make decision on scheduling the electrical home appliances based on the guideline price received from the power grid. This is to show how the power peak hour pricing graph is employed in the smart grid network price versus time of day. Here you can see from the local the smart grid connector at the afternoon. Am I right? So some place you see that some time or some hour, especially during some duration, maybe in the afternoon or maybe in the forenoon. But only some location you can see there is a peak arise and then it will be reduced. This is a complete scheduling algorithm employed for this particular case study. We have to generate number of samples of energy consumed by appliances using a PDF. We can generate it and we can load it as a different assemblies. Okay, with this different capacity. And then you see that there are a number of parts also located for the control operation, and then there is a scheduling operation. From that, you can identify how much electricity should be scheduled, how much data or information should be transferred during particular time. That should be stored and that should be evaluated properly during the scheduled trip rate. When it is satisfied, it should be scheduled offline, and then online tuning and online scheduling may happen, and finally we can able to control the different devices available in the house. And now, apart from this, when it is not satisfied, what do you do? You have to come down, right? No other way. And this picture shows the smart home scenario. You can see within our home what are the smart appliances we can use it. We can replace our olden technology into newest technology along with the smart devices. You can see there is a battery source, there is a PV panel, and both can supply the energy required for battery to store it, and for a refrigerator and ACs, and similarly oven, and there is a laundry machine. We can connect some uh, cable also, the security, sorry, what do you call, the flat TV also. So all are linked through the wire, and it is linked with the scheduler, where there is a smart meter is linked with that. Smart meter can able to monitor all the home appliances at the same time. It can able to send the control signal to disconnect or reconnect at any time due to the smart operations of the smart device. And you can see the energy from the electrical grid is actually taken to the different photovoltaic and sorry, the smart meter which is linked with the uh, grid. Through that, we can able to identify how much energy can be transferred and how much energy can be sell it and buy it from the grid. And this picture, this slide shows the exact devices which is present in the smart devices. Smart meter device, network access point, power company, and there is a control center where there is a monitor to see the power flow as well as the requirement for the different devices, when it should be switched on, when it should be switched off, and see what you can save, how much electricity we can save, at the same time how much tariff we can able to minimize it. Okay, let us move on to smart grid. Up to this, we have discussed what is IoT, what are the devices employed, what are the networks followed, what are the IoT applications, and what are the benefits, challenges, solutions. And finally, we have seen what are the other IoT applications and the basic smart uh, home connection, and where the IoT is employed to connect or disconnect with the grid. Now let us discuss about the smart grid. What is in the smart grid? Smart grid is an electrical grid that uses information and communication technology to gather and act on information, such as information about the behavior of the suppliers and consumers in an automated fashion to improve the efficiency, reliability, economics, and sustainability of the production and distribution of electricity. So ultimately, the main major goal of the smart grid is to supply the energy efficiently with high efficiency, high reliability, and sustainable production and distribution of electricity. This is the main focus on the smart grid. Smart grids include electricity networks like T&D networks and interfaces with generation, storage, and end users. While many countries have already begun to smarten their electricity system, all countries will require significant additional investment and planning to achieve a smarter grid. So already many countries they converted the conventional grid into smart grid and they employed successfully and now also and slowly they completely 100% smart city developed in some of the countries. And smart grids are an evolving set of technologies that will be deployed at different rates in a variety of settings around the world, depending on local commercial attractiveness, compatibility with existing topology, regulatory development, and investment. These are the further growth of the smart grid. When you are employed or when you are installed the smart grid system, after that, these are the improvements we can do it in its operation by incorporating some of the other variety of settings into the different smart devices. Just look at the slide. You can see the characteristics of the existing grid and smart grid. For existing grid, we are using electromagnetic mechanically. We are operating it as smart grid digital, and there is a one-way communication here. There is a two-way communication, and centralized generation is provided in the existing grid. But here be the distributed generation, and here we are using in olden days few sensors only. We are not using more sensors, but thousands of sensors are used. Not only thousands, this is take our example, but many sensors are. And there are some monitoring will be done manually, but here now self-monitoring is possible in the smart grid. And similarly, manual restoring. If there is any fault occurred, manually the fault will be cleared and rectified the fault and restore the normalcy will be done through by some workers or through manually it can be done. Smart grid it is done automatically through the network, smart grid network. And failures and blackouts are more, but here even there is a failures and blackouts occurs, so it can be islanded and the normal circuit system will be maintained continuously without disturbing the uh, supply given to the consumer. That is uninterruptible supply will be maintained. And there are some limited controls that are provided existing grid, but here pervasive control is possible in smart grid. Here many customer choices are there, but here many very few customer choices are available. That is, we are purely dependent on only electricity department. Olden days, right? But nowadays in other countries, even in India, some of the private power sector are encouraged to supply the power, and we have the private power generating companies like Geo or Reliance or anything else, Tata. These are some of the example I am showing. Apart from that, many other customer choices are there. So in your smart home, there are a number of options are there for customers. They can able to select which power supplying company can able to supply the power to the house, and they can able to see the monitor and they can able to identify what is the status of the different power supplying companies. Like electricity box, there is a big monitor will be there while the uh, power terminals are connected with the smartphone. There are a number of terminals will be there, and each and every terminal under the terminals there is a monitor. It shows what is the quality of the power which is supplied by the different power supplying companies. The customer can have the choice to select which power supply company can able to supply for their load, like frequency, voltage, power factor, THD, real power, reactive power flow, all the electrical parameters will be displayed. From this, we can be able to understand whether the quality of the supply is maintained or not. So from that, we can easily select which power supply company can able to provide the good quality. Likewise, we have many customer choice. Next, what is the concept of smart grid? According to the IEEE 2030 project, the smart electric grid or smart power is a complex end-to-end system that is composed of multiple sub-power systems interconnected and interrelated to each other through multiple protocols that combine multiple layers of technologies, for example, energy, ICT, and control or automation. Next, let us see the design direction, smart grid design direction. First direction is modernize the main and distributive networks, introduction of technological components of smart grid. This is the procedure we have to adopt in the first direction. Second direction, integration of the dispersed generation, especially renewable energy sources in the power system. And third direction is the introduction of intelligent account and of communication infrastructure for consumers. Okay, there are three major directions are employed in the design of the smart grid. Before designing it, you have to follow and you have to keep in mind these three directions are achieved or not. Just look at the slide, you can see the smart grid conceptual model. From the left hand side, you can see there are some intelligent control system to monitor the grid, isolate and correct problems and route power efficiently. And there are some smart homes with energy efficient appliances and electronics. And there is a commercial building, and there is a renewable source power generator uh, for consumer use and to feed into grid. That is solar panel which is located on the rooftop can be able to supply as well as this is the power from the grid. And you can see some of the other industries are linked, and there is a plug-in station to recharge the plug-in hybrid electric vehicles. While one is at work, plug-in can automatically charge it. And there is a user owned generator that can also feed power into the grid if needed, or sometimes they can use it for some emergency applications or during some power cut or shutdown. Some emergency lamping or lighting load can be applied through this user-owned generator. And apart from that, there are some smart meters for all end users, both commercial as well as residential customers, like home, smart home, and other small industries and companies. Okay. The next is main prerequisite for improving the management of energy. Right? What are the prerequisites required for improving the complete management of energy supply to the load or to the variety of consumers or customers? First, we have to separate the local markets. Then we have to identify who are all the emergency loads, like hospitals or police departments or healthcare mobile vans or healthcare uh, centers, increasing competition from local energy trading platforms. We have to identify which platform is having higher competition, and we have to see how to reduce the energy consumption by introducing the global strategy. Then finally, improving the quality of energy consumers in smart cities. These are the prerequisites for improving the management of energy. Now, this is a smart grid platform. You can see how all other power sectors as well as commercial loads and industrial loads are connected, and how the smart grid platform is developed. You can see in the both left and right hand side the central power plant and some of the other renewable energy power plants like windmill, solar power plants. And you can see there is a virtual power plant is also added. And apart from that, there are a number of storage devices to store the energy whenever during off-peak period it can be able to store it. And during peak period it can be able to supply the power through the storage components. And there are some micro turbines also employed, generate its own minimum power output through that micro turbine. And apart from that, the combustion heat pumps also connected with the grid. So likewise, the smart grid platform is designed and developed. The three generation of smart grid you can see here, the G1, smart grid 1, grid, smart grid 4, 3, grid 4, or grid 4. Actually, from the current state, that is original grid, conventional grid. That is, it may have analog devices or meters or digital meters, control system for local decisions. These are the characteristics of the current state, or we can say the conventional grid. And the smart grid 1 is having a response on demand, specialized devices, distributed automation. These are all covered by SG1. And especially network interconnection protocols that will be covered by SG2. Apart from that, power storage. Then SG3 for especially for power roaming, power trade, peer-to-peer connections. Then SG4 of IoT is especially on Internet of Things application and power smart grid. These are the different variety of characteristics which will be handled by the different development of smart grid stages. Let us discuss in deep smart grid 1.0, the state of authentication infrastructure in which individual devices and system objects can connect to the network without using general digital standards. Smart Grid 2.0, state of power infrastructure by which the connection of any system nodes is only possible under condition of switching to a unified internet protocol and interconnection of the nodes into unified integrated IP network. And Smart Grid 3.0 covers flexible power system that is based on the principles of decentralized control and equality of the consumer and the supplier. And SG architecture, from a technical view, the SG can be divided into three major systems. It may have infrastructure, management, protection. All three are combined to frame the technical architecture. A smart infrastructure system is the energy, information, and communication infrastructure underlying the smart grid. It supports two-way flow of electricity and information, and also it can increases the capacity and flexibility of network and provides both advanced sensing and control through modern communication technology. This is the arrangement for the smart grid network with the communication infrastructure in the middle, and you can see all the other components are linked together with the smart grid network through the different components. Left hand side, you can see all the power plants, conventional as well as renewable energy power plants are there, and there is a capacity and flexibility can be increased or decreased with the help of the distributed computing. And apart from that, there is a comprehensive communication networks are also employed here. And you can see the vector dotted lines for communication. And you can see a number of sensors, some symbol is shown. And smart switching devices, you can easily identify the shape of the smart switching device is shown in the network. And through other, apart from the distributed computing, there are a number of other substations also can contribute the power to the network that will be distributed through the feeders to the different variety of loads like transmission substation, distribution substation, load serving entity. And regarding loads through the different feeders, it may be directly connected with the residential customer, commercial customer, and multi-dwelling units, industrial customers. All are linked with the uh, smart grid network through different sensors. Everywhere you can see a number of sensors over there. Everywhere without sensors, no devices are connected to the grid, smart grid network. So through the sensors only we can get all the variety of information and data, we can collect it through from that, and we can use it for further analysis, and we can store it in the database. And whenever it is required, it can be able to evaluate each and every time. While implementing a LGP model, by step-by-step procedure is shown here. From the source, you can see the R&D research and pilot projects research are implemented, and then that from that data, the step one is identifying new generic use cases from the findings. Whatever the findings achieved or arrived through the R&D network or R&D projects or pilot projects, or when it is implemented, you can identify some of the new generic procedures or new generic cases. And the generic use cases, again, used for smart grid architecture model. In the step two, it can be able to map it with the help of generic use case data, which will be taken to the smart grid architecture model, and the model will be framed based on the generic use cases identified through the findings. And step three, the smart grid architecture model will be developed, and it will be locate requirements for the standards. As per the standards, it should be located. And step number four, identify the new gaps between the different standards. Okay, so with the help of the expected outcome and the real outcome, which is achieved through the smart grid architecture model, you can able to identify the new gaps between the already developed one and the present results. So from the results, we can able to identify new gaps, systematically investigate need for the new standardization according to the new process established by smart grid control center. Functional structure of real-time power grid operations. You can see the different operations which will be performed with the help of the smart grid functional architecture. So there is a central part, you can see there is an optimal estimation of states. So all the variety of analysis are employed here to get the optimal parameters from the each and every analysis. So once the optimal parameters are arrived through the analysis, definitely when it is implemented or activated in the control units or the control components or the places where you are going to send the remedial actions, definitely the result will be perfectly alright, because you are already analyzed and got the optimal values. So once it is optimal, definitely your results will be 100% perfect. If it is not optimal only, you won't get the perfect or accurate operations. So for that, we need to evaluate different algorithms and different analysis we have to complete it, like contingency analysis, automatic generation control, SCADA system, static state estimator, load forecasting, optimal power flow analysis. Like that, we have to do all the variety of analysis which is required to maintain the good quality of supply through the smart grid. So every time data will be received from the sensor, and each and every second this will be analyzed through the different optimal procedures and analysis to get the optimal. This is a structure shows the management of the power system on decision making. It is majorly divided into two groups. One is long-term energy management, short-term power balance. Long-term energy management, there are a number of analysis which shows which gives the results to the protection program, and protection adjustment can be done through the data which is received from the protection program. For protection program, we have to feed the data from the different smart devices like CO2 emission or electricity market values or load forecasting or renewable energy source protection, etc. and energy storage availability or load management. So based on all this data, the protection adjustment can done, and the proper load management system, we can able to provide the uh, RMS values like voltage control and frequency control. Can be perfectly done with the help of this results arrived through the load management system. And finally, it will be delivered to the power balancing device with the additional inputs like fast dynamic storage availability and power capability of renewable energy block device. And there are some DER, that is distributed energy resources, gas turbine plants and solid state breakers, etc. These are the examples I have shown. These are the devices will be actuated through the data which is released through the power balancing. So it is listed out here how it is performed. In the long run, there are number of continuous interactions between the components of the following management activities. A lack of functional approaches in their bureaucracy and benefit system in their consideration of the external environment. Therefore, to succeed in global competition instead of using the system, the technology is becoming smarter and faster, which requires a new definition of the role of managers. Standardization helps to reduce costs and increase profitability, flexibility, and ensures the survival of companies in the face of a changing environment. And contrary to market values or measured activity of less money terms and becoming increasingly important criteria for in the short run, briefly, seconds or milliseconds is critical time and information to make decisions. Within fraction of second, we have to take the decisions, right? Because power management in real time requires the introduction of a cybernetic system. Power grids and information system combination is shown in this picture. Along with the microgrids, the macro grid will be interconnected, and then the information will be received from all the microgrids and the microgrid, and then the information will be stored into the central microcontroller or the central smart grid control center. The implementation of the strategy carried out based on the concept of smart self-monitoring, analysis and reporting technology management principles, grid self-monitoring, analysis, reporting and technology. And smart grid, a set of organizational changes, new models of processes and decisions in the field of information technology and solutions in the field of automated process control system and supervisory control in the electricity. Let us see the model of SG operating. Appearance of new technologies from the joint of NTE, that is new power technologies, and NICT, new information of communication technologies, requires introduction in an action of standards that also must be set in a collaboration with the organs of standardization and divided by two areas, electrical networks and of informatively communication technology, ICT, that is information communication technology. Separate components of smart grid are an equipment of distributed network, intelligent meters, objects of individual generation. So just see the picture, you can see the actual control blocks are employed in the various operations, which is between the generation and the utilization area. So the power which is generated by the power stations are transferred to the ancillary power flow as well as baseline power flow. The power will be straightly supplied to the residential building, commercial buildings, and other lighting or heavy loads. Or sometimes it can be used for charging the electric vehicles. These blocks are employed like a generator, turbine, and there is a automated generation control. AGC control is also employed, and there is a feedback system also employed from the result which is received at the power system analysis. That is like a load shedding, commitment, economic dispatch, etc. This is a logical model with conventional domains for smart grid information networks. You can just look at the blocks. So what are the blocks are employed here?